Yeah.
That's a good one. You're right.
They should put lunch.
Well, no, there is. If you can't afford lunch, you get free lunch based on your income. The problem is it nutritious. A fresher lunch, I could argue for sure. Oh, I've heard that too. But they give breakfast, lunch, and if you stay after school for a club, you get another meal after school. But it's empty calories. What's that? Yeah, yeah, they don't. They actually want to give the food away because if it goes to waste, then they lose funding. But we should be growing more food here and then having more fresh vegetables instead of all right. There was a thing about having more water coolers, like more good water around. I think. Yeah, sometimes. Well, the construction and things, but yeah. But then what you're talking about is like a full like sewage, like that's a whole city thing, getting new water lines thing. Today we're gonna go with the quadratic formula. I'm gonna do something kind of crazy with you with the quadratic formula to start, but then once you have the formula, plugging in isn't too bad. You just need to take some time to practice it. So, hopefully you're working through these steps on completing the square. Okay. Hopefully by now you've moved C. You move C over. Then did you make a new C value by doing B over 2 squared? And did you write it on both sides? Then were you able to factor it? And then were you able to solve it? So hopefully you're moving through those steps while I'm totally off task over here talking about funding. Yeah, yeah, that's the math you want to know about, right? The real stuff. I want to know how much money we're getting for each of you. It's a lot. A lot of money. If teachers take a 7th period, they get 1 more hour of the day. But then they don't have any planning time, so they're working at home a lot. For the teachers? Yeah. So now we're gonna do, after you move C, do the formula B over 2 squared. So negative 12 over 2 squared is going to create a better C value. Did someone open the door for you? Okay, I should say. I don't think it's possible to unlock that door, but. Okay, so I got negative 6 squared is 36. The 36 goes to both sides. 36 is a better number. We're just doing bonus right now. Okay. After you create the better C, you factor. With your new C, you should always be able to factor. That's why you put that new C in there. So the problem is now x squared minus 12x plus 36 equals 18. Because we combine these two. Negative 18 and 36. Okay. So we factor the quick way. 36 square roots. So that's x minus 6 times x minus 6. So now we rewrite this. X minus 6 squared equals 18. So that's good for step 3. And Now that's step 4, solve. And this is how we started this chapter. Square rooting. X minus 6 is plus or minus the square root of 18. Get the 6 over. And then for today's lesson, it's pretty important that you remember, leave your radicals in simplest radical form. Simplify that radical. 18, what is 18? 18 is 9 times 2. Yeah, it's also 6 and 3, but 6 doesn't square root, and neither does 3. So 6 and 3 aren't as good as 9 and 2. Because 9 can actually square root to an integer. So my answer is 6 plus or minus 3 square root 2. All right, who's got a question about that process? So I'm going to put answers up now from yesterday's assignment. And so there's probably one or two where you did not finish. Probably the ones with fractions. Take the time now while I'm checking. You two finish them. I believe I showed 21 and 22 yesterday. But I'm going to go to 23 and 25. A lot of people didn't do 25. This is page 222. Did you do 25? Did you do 25? Here's 24. I don't know if I showed this one yesterday. 24 didn't have anything like extremely tricky in it. So if you're wondering, like, man, I'm getting some of this, I don't really get much of it, maybe just try 24. The numbers work all right. So 25 is more difficult, right? So I'm trying to tell you, like, figure out 24 first. Don't get to 25 and quit. I don't know if that makes any sense. 26 now. 26 is also a cool one. You get an imaginary answer on 26. That's decent. No. So you have a negative square here? You did negative 8 plus 4. Oh, that would do it. That would be easier. There's 27. You could use 27.
Yeah. I got x equals 2 plus minus 4.
Is your radical by root? Do you have a square root by root?
No, I could have a square root.
Cool. Yep. Then yours? Did you divide everything by 7? So whenever there's like a leading coefficient out there, the 7 and the very 5, you can't go. So you gotta divide it out before you go. Can't go with another from. Well,
Yeah, sure. There was no short dividing everything by 7.
these are set up like that, but like ACE math right now is doing completing the square, and every one of their problems has a lot of fractions in it. Not everyone, but a lot of them. So, like our problems this year is first time doing it. You divide by 7, and everything works out to integers. But as you get into more complicated problems, it doesn't always work out. You have to do it with fractions. All right, I'm gonna go to 28. Here's 28. Here's one. This could be in the ACE math. Because you got, instead of 1 divided by 2 working out, you have to work with 1/2. And 1/2 squared is 1/4. Yeah, well, it doesn't look right?
So I changed it.
Very weird. And maybe you solved with a 4 down here, and that's not wrong. But since the bottom can square root, you do it. So if you think about the numerator and the denominator separately, you can go ahead and square root the 4, and that's where the regular 2 comes from. Did you do this one with decimal correction? But then,
I still got the right.
what does it look like? This is just a decimal with an I?
I just did the square root of -1.75.
I got 1.3.
Guys, try not to.
It gave me 5%.
I'm really happy to see you guys working through these, looking at your work, seeing how it's different, seeing how it's the same, exactly what you should be doing. No, that's fine for. Alright, so historically, mathematicians, they did complete a square before they did the quadratic formula. Now, they show you in Algebra 1 what the quadratic formula is, but they don't show you where it came from. So what we're going to do now is we're going to figure out where the quadratic formula came from. Who still remembers the quadratic formula from Algebra 1? It goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
You like write, you know you write that.
I'm going to write it out a lot.
I actually know it.
You don't need to write this right now. You're going to have notes on it, but just as a refresher, this is the quadratic formula. You plug into it a little bit in Algebra 1. So what we're going to do right now, I'm gonna do it. This is a challenge for students. If you know you're going to A's Math, you should take on this challenge. Okay? If you feel overwhelmed and stressed out, just sit back and watch. Okay? So this isn't for everybody, but this is kind of this is in your book. This is a true honors level Algebra 2 math skill. Okay? So we're gonna use completing the square. To get x alone. Okay, so if you're sitting here with an A in this class, you definitely are doing this. Everybody can try it for sure, but I don't want to see anybody doing other things if you're capable. This is really difficult, to be honest. Alright, this is the standard form quadratic, ax squared plus bx plus c. We are going to solve for x without any numbers. Okay, we're going to get x alone. So we're going to go through these steps and get x alone. The only problem is that like we just talked about with the 7, there's an a in front. So our very first step will be to divide everything by a. And so that's now going to be x squared plus b over ax plus c over a equals 0. Okay? Yeah, quadratics are typically set equal to 0. So now we'll begin these steps. Let's move C to the other side. Okay? After you move C, you put in a better C by doing b over 2 squared. Lewis, take your earbud out. B over a all over 2 squared. You can. You're not supposed to divide fractions, right? So instead, we usually will look at it horizontally, right? Technically, that's over 1. Yeah, we don't really like to do that. So we'll just look at it, like horizontal division. And then we don't even do horizontal division, right? Don't we do keep, change, flip? Okay, so we're working that out. That's called a complex fraction. All right, so that would be b times 1 is b, 2 times a is 2a squared. Now b over 2a, we've seen that before. That's b squared all over 4a squared. Yeah, negative b over 2a is the axis of symmetry. Alright, so all we just did was find a better C. So the expression that we're gonna put in to our open spaces is this complicated fraction. B squared over 4a squared. I know, complete the square, no numbers. Pretty cool, pretty cool. Yeah. So after we do that, we're supposed to factor. Let me rewrite it. While we're factoring. Yeah. Wait a minute. Over here, like, this is what step we're on with numbers. We combine these like terms, right? So over here, we have to combine these like terms. Shoot. So I'm going to take a side note and I'm going to add these two fractions together. They'll need a common denominator. This is the only part of this that's actually above your curriculum right now, getting a common denominator. The common denominator for these two fractions will be 4a squared. Because this just has a, and this is 4a squared. The common denominator will be 4a squared. So then, right now, this little fraction just had a in it. So to create that common denominator, we would be multiplying by 4a on the bottom and on the top. So the top is now negative 4ac. Anybody with me on that common denominator? I can now combine like terms since I have a common denominator. This would be b squared minus 4ac all over 4a squared. Alright, okay, so that's still just here. So now to factor this, how do I factor this? This isn't honors, this is actually the very first thing in chapter 3.4 of your textbook is to do this. It's definitely honors level. But this is actually how they came up with the quadratic formula, the completing square process. Yeah. Alright, so now to factor this, you got a square root. We've been square rooting all along, so like here we square rooted 36. But how do you square root this? That would just be the square root of b squared is b. The square root of 4 is 2, and the square root of a squared is a. So this factors to be x plus b over 2a. And so if you know the formula, it's starting up here. Starting to see the quadratic formula here. After you factor, we solve by square rooting. So I'll put a big square root right here, big square root right here. X plus b over 2a equals plus or minus the square root of b squared minus 4ac. Why do I have a 2a here? I jumped. That is the answer right now. All over 4a squared. Subtract b over 2a. And we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So you can go ahead and square root that denominator. And there is the quadratic formula, in case you were wondering where it came from. It came from completing the square.
Who created this?
You could Google it. Like I used to do a project where we made posters of like mathematicians who like came up with different things. It's an optional 100 points. But doing like a poster of a mathematician. I don't know, yeah, maybe the end of this quarter. But it is cool to think about, like, yeah. So, but the point is, the reason it's useful is now every quadratic has an A, B, and C. Now we can just plug in A, B, and C, and the formula solves it for us. So the formula is like a really good tool. Now you don't have to factor, complete the square. You can just plug in here and it'll tell you the answer. Let's see that in your book. All right, here on page 229, this is where it says to show how to derive the formula by completing the square. But where you want to go is page 231. Page 231 is where the formula is typed out nicely. All right, I'm going to go ahead and take a look at this example. I'm going to fill in where your book kind of leaves things vague. Example 1 on page 231. All right, it's really important to note that to do the quadratic formula, you must equal 0. So first step here, they say write in standard form. What they did was subtracted 5. Is that too small? All right, so after that, you just identify A, B, and C. Alexis, can you tell me A, B, and C in this blue box? What is A, what is B, and what is C? Okay. Okay. A is 1, B is 3, and C is -5. So the number in front, the invisible 1 is A, B, C. You're just plugging them in here and here and here, okay? The hardest part of the formula, this is page 231. The hardest part of the formula occurs under the radical bar. This is where you really want to practice your order of operations. If you're getting it wrong, it's probably in doing these steps. So here you got to do 3 squared first and multiply all of this correctly. So -4 times 1 is -4. -4 times -5 is a positive 20. 20 plus 9 is 29. So this is where the work's at. Okay, either get really good at putting it in a calculator or do it sometimes with this. Actually, mental math is a little bit easier, or doing it step by step. All right, let's try one ourselves. Just turn to the very next page and we'll do number 6. Mine's blurry, it's so annoying. So this is page 233, number 6. No, just the quadratic formula. Nothing that I just showed you. Switch them. Set equal to 0. 233. Subtract that and subtract that to the other side. No, that's what's good about the formula. The A doesn't matter anymore. All right, so what I'm identifying here in number 6 is that A is -9, B is -30, C is -25. Yeah, I'm doing 6. Am I on the right page? Alright, so in our formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
You have to move it around first.
Yeah, move everything around. Make it equal 0. So we got a negative 30. Get your calculators, you know. 30 times 30 is 900. I believe. And then we gotta do 100. I think that's 900 again. That's annoying. Gabe, are you doing this number 6 right now?
Huh?
Are you doing this problem?
Yeah.
You got a 0 for your square root? Where are you at?
10,000.
Oh, yeah. That's not what I got. Anybody get 900 minus 900?
Yeah.
Is it? Everybody using the calculator?
Wouldn't it be 0?
That's 0. You just plug it in so it's like you can, if you're doing it in your calculator, you can plug all this into your calculator. You can't do the whole thing, but you can put all this in your calculator and do it for you. You get it. Yeah, let's see if anybody can get 0. Use your parentheses, use your negative sign.
Oh, you can't do plus 3, can you?
No, the plus or minus is what you can do. So just do the bit out of the radical bar. Zero.
No. I was just saying you did.
You don't. You literally drive yourself up. Alright, the square root of 0 is 0. So a lot of times there's a number there, and you're stuck with a number. This time, the 0 just kind of goes away, and it's 30 over 18, which would be, what, that both divides by 6 if I reduce it? So that's negative 5 over 3. It's actually easier. I mean, than the it's easier than factoring for the most part. And but you get silly with what I just did at home, revising it. Alright, anyway, your assignment is online. So, but if you want to